Hello everyone. Thank you for attending this new CivilFEM webinar. I'm Ronald Siat from Inge Cyber company, and we will today show you a short introduction to Python analysis in CivilFEM 2016. Okay, this is our first webinar regarding Python programming. As you know, CivilFEM can be used using the interactive mode, using the graphical user interface through its windows, menus, toolbars, and the different its different windows. But some of you maybe don't know that Python can be used instead of the graphical user interface. So first of all, what Python? Python is a programming language. It's developed under an open source license, and it's an interpreted interactive object-oriented programming language, and we'll see how it's integrated in CivilFEM using different tools or windows. This Python will help us in automating and customizing analysis, saving us time and space, because it's always the size of these scripts or files, Python files, are always much lesser than an actual model size CF or XCF file of CivilFEM or the database. Okay, you will see that it's only some lines, and some will never be more than some kilobytes. Okay, of because it's a text file. To use by using Python, everything that can be done through CivilFEM, defining the geometric entities, materials, sections, mesh, applying loads. Okay, can be done. It has its own every tool, every capability of CivilFEM has its own command. So as any language, it has conditional logic and looping statements using the if command, while command, and for command. And if you Python can be easy to pick up whether you're a first-time programmer or you're experienced with other languages. Today we will just show you some basic Python, some basic Python in CivilFEM, and the following webinars we will go further with more advanced options. But here you just want to just show you what we can do and how we interact in CivilFEM using Python. Okay, how to once we if we want to run Python commands, CivilFEM commands, we have in CivilFEM the script editor and the command line. Okay, CivilFEM has its own editor to run Python code, and we can, of course, we can use external editors, but we have our own window. Our own CivilFEM has its own window, which is called the script editor, located in the view tab inside the Windows menu group. And as well, we have the command line. We will see the difference between the two windows. If I open the software, many of you already opened the software. If not, you can download the student version through our website in www.civilfem.com, and you can go download a free version. Okay, once we have our graphical user interface, we go to the view tab, and just make sure that you have highlighted these two windows, a command line and the script editor. Here's the script editor. It's it's another window. It can be placed anywhere, as you know. It's a dockable window, and we have it here. I placed it in the same position as entities and groups view, and we have different options to create a new file, open a new script file, to save as. We have a very useful capabilities as undo and redo, and to run and to stop, and as well we can change the font size here in this pull down menu. Okay. Of course, we have as well shortcuts. We have hotkeys if we want to, as you can see, a new Control plus N, Control plus O, Control plus S, or Control plus A to select everything. Okay, Control plus X to cut, undo, Control Z, Control Y, F5 to run a script. We have many options. What's the main difference between the script editor and the command line? Here we can place a full script. If we have already a full script, we can open it, okay, and we can run from here the full script. But in the command line, we will run just a single command lines, only one by one, and by pressing the return key, it will launch the command. Okay. We will show you some examples so you can see how's the workflow of Python in CivilFEM. First of all, as I told you, we can always use external editors. We recommend we use Notepad++. It's open source. It's free as well, and we can always if it's a Python language, it can be automatically detected or selected from here. In this case, as you can see, we have a Python script, and if you want to run it here, we can open it, or we can write directly here in our window. Okay. If we have different commands. Python, we have Python. Okay, of course, Python, all the Python basics, and of course we have all Python commands, but related to the CivilFEM software. As you can see, we can create everything that is done using the menus, creating geometry or materials and other things. We can use its Python command. For example, this I can show you this first line is the same as clicking here, new 3D static structural analysis. So it's the same as doing this line. Okay. If I open the other editor, here we have another, for example, another lines. As any programming language, we can define parameters and different variables, different data types. What are the data types in CivilFEM? In Python, it's the same as in other standard programming language. We have different parameters. We have a floating or double data type, which is a real number. Okay. We have integer types. We have lists, which are an array, a vector. We can set different values for a vector or an array. It can be a matrix or a 1D vector, a 2D vector or array. Okay. We can define strings as well. We can define characters. And well, once if we want to see the different CivilFEM commands, we can have the help of two utilities. Okay, if we continue, here's the how is Python integrated in CivilFEM. And now, if we of course, if we want to start from the beginning, it's well, we know nothing about the CivilFEM commands. So even if we get a Python manual from in the internet, we know how to define our variables or loops, or we can learn how to define our if conditional statements. But we need to to know the CivilFEM commands, how to define a point, how to define a line, or how to define a structural element, how to mesh, how to get results. Okay, so a very an easy way to start is to start the macros. The macro tool in CivilFEM, it's very similar to the Office in the Office products. You just once you want to start doing something, you want to save that process, you activate the macro, or you start the macro recording, and everything that's being done through the graphical user interface, through the GUI, it will be saved into a script, Python script. And then once you have that script, you can modify it, change the parameters, and then you can run it, and you can run it again. Okay, if we go here to CivilFEM, we'll start a new analysis. If we go to the View tab, and I click here, start macro recording, I save it into my working folder. I set a name, for example, this name, or a new one. Now, okay, I can start working with CivilFEM in a standard way. I check my units. Okay, I want my international system units, and I want to define 2 points, and then a line through these connecting these points. For example, a line which will be connecting this point to this another point. Okay, 2 points, and then I want to define just a referenced line between these 2 points. 2 point here. Here I have my line, and now I want to define my my material and my section. Any section, for example, IP300, for example, and I want to define my structural element, which will be the beam with this geometry. Okay, we'll leave the default values for the mesh. We will create 10 finite elements, fine beam finite elements. I mesh, I save it, and I will have my beam element here, my beam structural element meshed with 10 beam finite elements. So now, if I want to stop my macro recording, I just open my file, which was saved before, and I have here my CivilFEM commands. If I put it bigger, the font, you can see here, this file which was saved. So now the first line is very important. This line is just a coding interpreter, so it will be always needed to allow the software to recognize and to avoid any conflict in the interpretation of any character. It can be international characters or international symbols. So all of them can be detected perfectly with no conflict, with no any problem. So it's always recommended to insert this first line as shown here. Of course, it's always added here, once we open our script editor in CivilFEM, it's always included here. The next the command line, we always recommend to put always the new document, this one, a line very similar to this one, okay, which is the, if we want to create a new document, we set here new document. I didn't tell you that if you want to write here in the script editor, you can start typing, and you can use the autocomplete button, which is Ctrl plus space bar, and you always can click start writing, and then pressing Ctrl plus space, and you will have this command. And if we want more details of this CivilFEM command, we always can use here. We always can use this interpreters manual, the CivilFEM Python script manual, and if we want any help on any CivilFEM command, we have it here. We search it and we go to a new document. We will need the dimension, the time, and the discipline. These are the different enumerates for this command, 2D or 3D. And the type of analysis: static, transient, modal, harmonic, and buckling. These are all the capabilities that are here shown in the, as I showed you before, here when we open a new analysis. So this is the first line, and then the units used in the international system by default, and then here are the geometry that we have defined. If we want as well, if we want to set here if we want to use the autocomplete button, we just Ctrl plus spacebar, and we can always see here the different options that we have. And if we want to check which arguments or what we need to create a point, we can search here and to know more about this command. And here we have the information about this command, CivilFEM command. A create point, that command will create a point in our following according to the global Cartesian by default. We always can set an alias. This is a short name for this command, PNT. And depending if the point is referenced or not, if we are using a vector or not, or we just set the name and the coordinates of the point, we have many ways to define a point. The same options as we have here: point by on curve, on surface, or referenced or not. We have different options to define a point, and they are the same here. In this command, I can replace the name of the command by its short name, by its alias, and I can set here. You can see here the arguments needed for this command to create a point. We need or not, but in this case we set the name, and after defining it, I can modify it. For example, point 1, point 2. All the character, all the string data types will always be between quotation marks, okay, to define the name of that point. And then the vector, it will get the coordinates of the point. In this case, it's according to x, y, and z, minus 10, 0, 0, and my second point is 10, 0, 0. I can create a line, and if I want to as well here, I can use always again the autocomplete on to know here how to create a line. I can search in my manual, and I see here how to define a line. In this case, we have defined a line between our origin point and our end point. So here we create a curve. We can set a name, and through these points, point 1 and point 2, it's the same. So I can save it, or always can change the file which was saved by the macro. Okay, and then here is I deactivate the visualization of the grid, and then I have defined my steel material. This I create is here, and then the section, the IP300 section, it has defined here. Then the following step is to define my structural element. My structural element, which is I set the name beam with this cross section in Y and J ends, and with this geometry, which is the curve. Okay, in this case will be curve 1, because I have changed the name. Okay, and then CivilFEM always we set different variables. It will be easier as here to set the geometry, and here to set the structural element beam. The beam structural element was saved in this into this variable, and the geometry into this one. To refer to it in the creation, in this case, of the structural element, it's always used these brackets. Square brackets. Okay, the same here and the same here. Okay, so another very important thing. If we save it, if we want to open it here, we will see this one test. It's already here, and we can run it. Well, if always check the output window, just in case, because sometimes we may have some mistakes. It will be shown here all the warnings and errors. I save it. Okay, and it's done. So you can see that that everything that has been done before using the graphical user interface, now it's it's saved, and we can change always. Of course, we can always change the parameters, or set a parameter here. Okay, we can set here a parameter, and then replace it here, and it will take the all these values, or even my list of materials. I can change it here, or my shape. I can change it here, and if I run it, it will be changed. If we want to save it automatically, and we don't want the software to ask us to save our file, it's very useful to set our one line, which is the save as command. Okay, if I can set it here before meshing, as you know, always when we mesh, it's always the software always asks there's a pop-up window asking the user to save the file, the database, or not. Here, using this line command, I can save it with this name, and this other Boolean argument just is asking you if you want to replace or not the existing file. If it's set to true, it will replace it without any warning. So okay, so now here it will be meshed automatically. Okay. If we the difference, as I told you before, the difference between the script editor and the command line is that the command line will be used only as a single with single instructions. In this case, only it will we can enter one line command line, that's one by one, and once we, for example, if we, in this case we want to just mesh, we just click here, and it will be and if you use the cursor buttons up and down, you will always have here the other commands that were used before. So we have a history of commands. Another very useful command here is, for example, is the help button, the help tool. For example, any CivilFEM entity, we can get help from it. If we run the command line, it's, as you can see, it's the variable name of the variable help and open and close brackets. In the output, we can see the different attributes of this structural element. This is our structural element. That's a beam structural element, and we have here all the options that we have to modify this structural element. The name of the beam. Some data or some properties are not modifiable. Here you can see that well, once you have meshed, some attributes cannot be changed. Well, if we just clear, you can see. But here you can see that we can access to the material, to the geometry, some meshing info, which are all these, and the cross sections used. So everything shown here are the different attributes of this structural element. Okay. Well, if we go back to our presentation, here we can show you. Well, I have shown you how to obtain a macro of our CivilFEM commands, how to access to the interpreter's help, which is installed with the software. It's in the CivilFEM 2016 menu. And another important document is the as well. It's not shown here. It's the CivilFEM Python manual. Okay, the Python manual. It's a PDF document. It's located in the installation of CivilFEM as well. You have more explanation of how to deal with Python in CivilFEM, the basic data types, syntax considerations, well, different commands, utilities, how to define a loop. Now in an example, I can show you all this, well, summarize all this document in short basic examples. Another important command, if we want to use paths for, well, for example, opening a file or saving a file, is this way of defining a path. Okay, it's very important that we use this letter, the R, before the path or what we are going to save into quotation marks, but always this R that means row, but that because it will take the path correctly, because sometimes some commands it will give any conflict because it can detect that a new directory will be created or not. But if you want to, for instance, here I just saved my, in this case, in the software, I just saved this file here. But if I want to save it in another directory, which is not my working directory, for example, here in CivilFEM. Okay, and I must always set here an R, so it will give me no problem in the interpretation of this command. Okay, if you have any problem, always go to the output window and see if there's any problem. Okay, in this command just saved my file, my database, into this working folder, CivilFEM. Okay, if I go to see CivilFEM, it will be here saved. Okay, so What else? Okay, I was showing you the Python manual. Here you have a very good explanation of the basic types and how to define the variables in CivilFEM, how to activate or deactivate the script editor and the command line, and my shortcuts or my hotkeys for the script editor, the autocomplete. Okay, and the help, he's shown the help function that will give you the output attributes of each class. Very important. And now, I will continue to explain all these things, but by using some simple examples. So in this case, we have just a simple building, and we as we have said, have seen that that some parameter or some can be automated, some workflow, some processes can be automated, because here we have a certain number of columns or beams and separated by certain distances or heights. So if we think about it, half an hour before to decide how to define our geometry, to set conveniently all the names, because later it will be useful for the loops to define our geometry and structural elements by just a simple codes or simple rule following the different floors and position of the beams and columns. We can set some loops and define our full building in some just some lines, saving costs and time. And if you want to set parameters, we can use this Python code to set different geometries in just one file, different geometry, just by changing our distances or heights or any variable. It will be easy for us to have a very powerful script. So I will show you here my main Python script. As I told you before, the first line is this one. Always you can it's better the more commented the more commented the Python file, the better. So always use this this symbol, okay, to in this editor, just by clicking Control Q. Okay, you have the option to comment or uncomment. Just always start with the new document command, and then we can set all our parameters here before all the CivilFEM commands. We can set here the number of columns in one direction and set the distances of each of one column and the next one in one direction, and the same for the other direction. Here you can see we have columns in one direction, X direction, and Y direction. So we can set them here, and as well we have different number of floors, and we will set here the height of each floor. Okay, the thickness of each floor or each concrete structural element, and some data for the mesh and for the cross-section dimensions. So it is very easy, very easy to understand. Just to create the concrete material, the reinforcing materials, and then the sections. So if we go here and open this file, okay, we can run the file from the beginning until the section definition. And to do this, it's where we can use the command line and this very useful utility, which is run a Python file from one line to until a certain line, not all the files. So if you want to run from line 1 to line 31, for example, you click enter, and we will have here defined our materials and section. That's all. Okay. The geometry will be defined later, but here we have our materials with all the default options. If you want to change anything, we can do it here, or of course change it in the Python code. And here we have defined our dimensions, and are here for the two sections. One section for the beam elements and another section for the column elements. Okay. So what's next? Then now we have seen that it could be useful to create some loops for the points and other entities definition. For this case, we have that we want to place points, points in our graphical in our grid to define the position of my the connection of my columns and beams and each vertex of our floors. So we have defined three loops. They are nested loops. One in y in x direction. It will place a point following the lists or the arrays in each direction. We will place a point at 763 meters. I didn't tell you, but these dimensions are in the international system, so they are in meters, and then in y will we define as well points following these distances, and then we will repeat this process, but for its height. For in this case, this is our first loop. Always our loops have this definition, the for command. If you are used to C++, it's the same, and x will be the iterator. We will iterate between some values. Some values they will follow a range. In this case, cx is defined here. So x will have the values of 1, 2. Sorry, all the loops at the beginning 0. So x will iterate between 0 to 4. Okay, so it will create 5 points, and with to define a point, we will need first the definition of the name, and here's the definition of the name. The definition of the name will have p as our first letter, first character, and then we have this what we have defined here. It's a mnemotechnical rule. It will have the number of the floor. It will be z. Z will vary between, you said here, 7. 7 will have seven floors from floor 0 to the bottom of each column to the top of the highest level or the highest floor. It has 8 different plane of nodes, one in different each one in different level. That's why z will change between 0 to 8, and then y we will iterate between 0 to cy, which are the number of columns in y axis. So it went from 0 to 5. We have 6 points. So it will take the coordinates from this vector, and this vector has been defined here. And then this is for x, and this is the loop for the y direction, and then the same for z. So we'll define 7 or 8 plane of points. So if we go here, and run from the line 33 to line 46, we can here 30. Well, it doesn't matter because some lines are commented, but well, we'll make nothing but here until 33 to 46 because we have already defined materials and sections. Just click return, and here you have all the different entities. We go here and geometry. We will see how we have defined we set the name of each point. We have defined these names. Okay, the first word character is the P, and then the next digit is will define the floor. In this case 0 is the ground floor, and then we have set different when the the following one, the third digit and the fourth digit will define the row and the column. In this case are the first row 0, then 1 row, second row, third row, and then in columns the same. 01, 02, 03, 04, and so on. And if we go to the second floor, we'll have another coding. P1, it will refer to our first floor. And so on with the rest of the floors until the points of our last floor, which are the P7 points. Okay, so now that we have defined these names, it will be easier to create our lines, because for vertical lines we can follow all the points with some names, with the P0 to P1 to P3, P2, P3, P4, and so on for verticals, and the same for our that for columns, and the same for the beams. If you want to place beams, as well as we know and because we have set the different names of our points, we know how to perform a loop, and how to which will be our initial point and end point, because we know the names of them. So we can set in the script editor. Here you can see in our next lines, for example, well, this command is just to center the view, make zoom fit to fit the view in the view in the window, in the main window. And then here we can set the different loops for our lines, and we take advantage of these loops. They are again nested loops, one loop inside another ones. We have set as well the different structural elements. Okay, of course we can do it always one by one. Of course we can always set do it. We can always mix the definition through Python and the graphical user interface. Okay, so here we can always do it just by clicking, but the thing is that, well, we want to do it well, not manually. We can do it. We want to do it. Okay, here we have our lines. Want to do it well following Python, and then if we want to do it right, we have to to change maybe the name of our column 01 one by one. We have to change them as well, but in this case it will be easier if we as we already know the names of the points, and we can following a mnemotechnic rule, we can set the different entities. So in this case, if I open again the main script, here we have set the line. The line will have as well the name. In this case, we'll have for the columns the C character in the beginning, and then it will take the number of the floor and the position of the X and Y and Y coordinates. Okay, so this tool, this capability string, just returns a string or a character name for this argument. Okay, so see for each iteration, this will return a number, but this will be considered as a character to set the final name of my entity. In this case, a line. That's why it is used this str command. It's a basic standard Python command to return a character, a string value of what's inside the brackets, because it won't be taken as a floating or integer. It will be taken all this as a character, as a string, and it will be the name. Then it will take my first point and my second point. Okay, in this case, for each floor, it will define my line from one point and and just the one above. As we know here, one point which is in one level, it will be connected to the one point which is just in the following level. It's why we just set here z plus 1, and then the same for each location. And then what's next? Next is to define my structural element. My structural element, it's a beam structural element, will take the same geometry, and we will get the name of my cross section, the cross section that has been defined here for the columns, the 40 by 40 centimeters. Centimeters. Okay, and then we set here the mesh options, which is will have a length of this parameter, which is defined before, 0.5. Each beam element, finite element, will have a length of 0.5 meters. Okay, so if I go back here, if I want to run from the beginning until these vertical lines, just go here, run 1, 2, 55. Okay, now I have my points and my vertical lines. As you can see here, automatically I have defined all the names. If I go here, I have defined all my lines. C1, C2, C3, and as well another code which will define the floor level and the points which are connected, all the 0 points. And this one are all the points which are connecting as you see here, the P101 to P001. So it has this coding. It will take the same name, a very similar name to the points connected. So these are the vertical lines. We can follow the same procedure, and of course the same for the structural element. I have defined one structural element for each column with this length that has been defined before. I have set the geometry and the same name. I have selected the cross section, no offset, no hinges, and these mesh options, mesh controls, uniform length of 0.5. If I want to get some information or to change these attributes as well, we can make use of the help button. In this case, the VC. We can set here the VC command, VC variable. We can set the help of this. The output we can see here for the last column defined. We can access to these attributes. If we want to, here you can see. If we want, how do we know to set this enumerate? Okay, how to in this case, if we don't set these lengths, it will take by default the default values, which are always the 10 elements per beam. But to know these parameters, okay, how to deal with them, we always use this help button, and we can always access to this. For example, for mesh 1D, if we go here, at help, it will give us, sometimes if I don't put it right, it won't give us, okay, here, information. Here are the options for that attribute. For mesh controls, we have this option, maximum length, and the value, which is here. Okay. Well, this is the same as we as well. If we activate the macro and do it manually, if we set one by one the different structural element for each, define one structural element for each column with these parameters, okay, it can be done as well. But this is the power of Python, that it can be done using some simple loops. So for the horizontal lines, we have two horizontal lines. There are beams, but some beams are in following the X direction, and other beams are following the Y directions. And then, of course, we have the different floors, which will be connecting each vertex of our floor. We will have 4 of them, but in this case, the same. We follow the same procedure. Okay, we create a line between this point and this other point, and then this one to the next one, and so on, and for each floor. As we know the names of these points, we can set here the same a name for each beam, selecting the point that we already know, because we are following a very easy rule. And then the next part is to define my structural elements. Okay, so if I go here to my script editor, I can run now from lines 56 to 73. Okay, from 56 to 73. And the good thing as well is that if I made any mistake, I can just run again the script from the beginning, and that's all. I don't, of course, because if you have to do it again manually, it will take more time. So here we have the horizontal lines following the X direction. As you can see, they are now BL lines connecting. Well, this is for the first floor, the BL2 for the second floor, BL3, and here you have them, BL4, and now we have the other transverse lines connecting these other points in Y direction, And in this case, we took advantage as well of the loops, and we have defined the surfaces. We will define a surface. I can do it here. It will be the same as defining a surface through 4 points already defined. I will define a surface between this point, this point, this point, I'll start again, this point, this point, this point, and the last one, this one. Okay, I will create my different floors, but as I am already have my points defined, I can define it using Python. It will be a quadrilateral with this name, with F for the floor, and using the each vertex for each floor. This one. So all these points and these points, all the external points will be, and here at the edge will define my surface, each surface. And then I have defined my shell structural element. In this case, will be shell elements. This is the command. I can search it here in my Python script interpreter. Okay, how to define a shell? I will need my material, a thickness, and associated geometry. Okay, and here's what it's. Here's the name, the material, thickness, and the geometry. The geometry will be each of the surface that has been defined before. It will be meshed with quadrilaterals, and the size of each quadrilateral element will be 0.5, the same. Okay. So, and the next part will be to save to save my file. Okay. If I open it here again, I will run it until from the beginning until before saving, before meshing 676. My points, my vertical lines, and my surfaces. Here we have them. Okay, we have defined our columns. We will be separated the distances that we set here, 7, 7, 6, 3, and in y direction is 6, 5, 4, and 3. If we want to measure them, we can check the distances between points. Okay, between this one and this one. You can check in the output. Okay, 3.5. This is the distance of the height of my first floor. Or we can check the distances between the horizontal columns, 7, 7, so this one, and the same for this one, 6. Okay, in y direction, 6, then the next one it will be 5 and 3. Okay, 6, 5, 4, 3 will be the distances in meters of each column in y direction, and another different ones in y directions, and different different distances from one floor to the next one. So, well, the last part will be, well, saving. We can save it and mesh. If we want to merge all nodes, it will be the same as doing it here and then merge. So if you want to run it from the beginning, it's already here again. It will take some time for the mesh. will be saved to my working folder, and here we have our structural elements already meshed for beams and columns. Okay, here we have them. So well, what else can we do with Python? Now we have meshed. Now, well, we can set some loading, and will be interesting, for example, to set some loads if we want to place them. Well, if we want to, for example, start a macro and set here a macro for the loads and see how to define some loads. I want to create a new load group for some surface load, floor 1, for example. If we want to place here a vertical surface load of 1000 pascals, it will be defined here. Okay, and if we want to repeat the process, we can copy this for for the next floor, or we for example this one. Okay, and and so on. But if we want to automate this process, we can use Python. Of course, if we will be easier to select first all the floors where we want to place the same loading, for example, or these four floors. Okay, we make a current selection, and we use Python again to place here some loads. Here, if you want to explain this new Python script, here I save into my list of all my structural elements by selection. I will get all the selection group. In this case, I have selected these 5 floors. Okay, and they are here. They are saved into array selection. I create my load group with the name of vertical pressure. I set a value for this pressure, and I iterate in all my list of structural elements. And I will add a surface load, the one defined with this value here, with this direction, and then I plot my loads. Okay, if I click here or I press F5, here we have them. Okay, in one Python script we have defined the very fast way the same vertical pressure in different levels. In this case we have only 7 levels, but if we want to do it in 100 floor building, it will take the same time. But if you want to do it instead of using Python, using the graphical user interface, it will take more time. Okay. What else? For example, sometimes we can start defining names for our structural elements or geometry, and we at the end we have decided that we want to change the name of our structural elements or geometry, and instead of these names we want to place another ones. Okay, we can do it manually, for example, Okay, floor, or instead of F, want to set floor, or and so on, or instead changing these names, we want to change some dimensions, or remesh with the different edge size, or whatever. Okay, instead of changing the one by one. Okay, we can, of course, using Python, and in this case will be, well, I show you an example. For if you want to, here you have it. So what we use here are the containers. If I open here the Python manual, here are the containers. The containers are all the entities properties. We have containers, a container for all the coordinate systems, for the geometry, for materials, for sections, and so on, structural elements. So we have containers for each box of entities of this window. So we can iterate inside each container. So that's why it called we can find some entities inside each container and change anything. Okay, here for example, you have a how to okay, change all the structural element with this name, and we'll change the edge size to a new value. Okay, but in my case, I want to just change the name of my entities, my shell entities. Instead F1, F2, F3, I want to set a stage, or floor, or a story, or whatever. So this is the loop. For S, it will be the iterator. All the elements which are in the structural elements container, it will look from here, from this element container. It will search where F is the letter F is in the name of any of my structural elements, and it will replace it by stage. Okay, just click here, and here you have them. It's already changed. Okay, so well, as you can see, we have many options to interact with Python in CivilFEM, but of course these are only some basic tools or introductory tools. Of course, we have more advanced Python tools using external libraries. We'll show you in the next Python webinars that there are external libraries that can be called the math library for using formulas, the typical functions, trigonometrical functions, or to use to plot charts or graphs, the matplotlibs, or use operation between different arrays, or matrix operations. We use the NumPy library. Okay, and we can of course access to any data or results from CivilFEM, coordinates, results. We have the get function. In this case, we have defined. We can define, for example, a load which depends on the coordinate system. For example, we'll show you in the next webinar how to define a hydrostatic load, or hydrostatic load which is not following a triangular shape. We can follow another shape which will be, for example, following the Westergaard equations. We can follow a parabolic function, or any other function. We have it here. Okay, we have here for next Python. We have here how to define well. As you can see, some commands are more advanced. Here we get all the coordinate location of my nodes, and then I define my equation. Okay, my pressure equation, and define my loadings. For example, if I can my NumPy library. I will show this in my next webinar, but I want to show you just now. You can see here, this is a 2D dam, and you can see here, you will see here how is defined the hydrostatic. If you can see, you can appreciate that it will follow an equation. It's not totally vertical. It will follow. I can change here scale factor. Let me check. So we can see here. We can see the shape. Okay, it's not totally triangular. You can see that it follows an equation, and any equation can be defined, of course, in Python, and that's why it's very powerful. The control of the Python commands in CivilFEM. And then, of course, we can plot charts and advanced charts, creating videos, and or taking images from results. Okay, so we have plenty of other advanced options in CivilFEM that will be shown in our next Python webinars. And of course, we have more CivilFEM courses in our International Online CEA Education Center, or Computer Aided Engineering Education Center. We have the introduction to a finite element method with CivilFEM, and dynamic analysis and nonlinear analysis. Every 15 days the enrollment is open, and you have more information in this website, in ICAEEC.com, and as well we have more our international masters in theoretical and practical application of finite element method and computer-aided engineering simulation. And this next course will be our 23rd postgraduate course. Registration is open. The course will start in the beginning of next year in February. And as we announced that we have a new Python programming course in our masters. If we visit our website from the masters, you can get information of this new module L, scientific programming language, Python. Okay, and it will verse about the basics of Python, introduction to Python language, and apply using a CivilFEM as application software. And of course, we will have practice problems as well. Okay, we go here if you can access to this new student manual course. You can see here in our module, on the module L here, the new Python programming language. Okay, here you can see all the in this student document. Okay, the construction branch guide. You can have the information of this new Python module in our masters. And Of course, thank you for your attention. If you have any question, you can place it in now in the application. Of course, always visit our website so you can see the complete list of webinars from us or from our channel partners. For instance, we have in December two more webinars, and then in the next year you can have here follow a complete list of our webinars. So thank you for your attention. If you have any question, you can place it in here with the chat, or you can write to using these email contacts. And of course, if you have some time, you can after this webinar will pop up some questions regarding the interest of this webinar, or if you're interested in more courses, or okay. Thank you. Please, if you take some time, we will appreciate it. Okay. Thank you very much, and bye bye.